Okay, my name is Akira Nordmeyer. Most people just call me AK. I'm here to talk to you guys about everything you guys use in your laboratory, chemicals. Where did they come from? How do we get them? How are they so purified? And basically, we can get them in large quantities. Before days, we couldn't do this. Nowadays, what we do is we use what's called batch reactors. And what batch reactors are basically giant vats that we build that have a mixer, and we grow in bacteria for different types of chemicals like acetic acid, ethanol, and glucose production, things like that. All of this can be done through the batch reactor. Now, there's a lot of pros and cons to batch reactors. They, first off, take up a lot of space, right? You're looking at housing thousands and thousands of gallons. You're able to continuously mix them, but between each process, you have to empty it out, distill whatever you need from them. So if it's acetic acid or ethanol production, you need to distill it. Now, then after that, you have to clean your batch reactor and regrow your bacteria, then refill in the chemicals you need in order to make your acetic acid or ethanol or acetone, things like that. Now, what we can do nowadays is we're trying to look into what's called continuous flow reactors, which basically is able to miniaturize this and give us not batched, but continuous flows of chemicals. And there's many different designs for that, as such that we have our wastewater stream, or our chemical stream going in, and we are able to fill this tube with our bacteria in an isolated cell. So most commonly, they use bacteria in cell drops, which basically are glucose filled with a little bit of salts in there, and they are beads with our bacteria inside. Now, as our liquid goes in, our bacteria is able to reduce whatever chemical is in there, whether it's a glucose solution or a salt solution, and then produce our waste stream with the chemical that we want. So now all we need to do is do a basic distillation like we used to do before with the batch reactor. Now, the idea of the continuous flow batch reactor or continuous flow reactors is that you want to increase the amount of surface area for your bacteria to be exposed to your flow. Now, if you have too much, that means your chemical concentration that you're looking for to be produced gets too strong by the end of your reactor, and therefore the bacteria on this side get exposed to toxic levels of your chemical. Now, if they're too toxic, or if the pH drops too low for your bacteria, these bacteria are going to start to die off, which means your battery or your continuous flow reactor is going to lose efficiency. Okay? So the idea behind the continuous flow reactor that's being looked into is optimizing your surface area to your concentration gradient. Okay? Now, a lot of research is going into this for mostly ethanol production. Ethanol, as everyone knows, is a biofuel that is commonly used through sugar in wastewater, and we all have wastewater. Every city has a waste sewage system. There's sugar in there. There's also plants, like not plants as in growing, but plants as in manufacturing plants for sugar, like beets in Brazil and in Costa Rica. There is sugarcane. These plants that produce sugar for us to use in our coffee, for example, have wastewater streams that are in high concentration of sugar. Now, the continuous flow bioreactor would allow us to obtain larger amounts of ethanol production faster than our current batch reactors. So that is the reason why we are looking into the continuous flow bioreactor, and hopefully it'll be solved soon. And that's the end of my talk. 3 minutes. How long was it?
2.5 minutes.
Ooh.
No, I'm just kidding. 4 minutes and 50 seconds.
Woo.
You're up there, you have no idea.
Well, yeah, because I thought I started at the 3, and I was like, ooh, I think I cut it a little too short.